Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on analog filter in IIR filter design. Next one, empathy in IIR filters. First one, fast response. Quick processing enables real-time applications. Hardware complexity, minimize hardware requirements for cost effectiveness. Channel selection selects optimal channels for efficient signal transmission. Power consumption, low power usage ensures energy efficiency. Signal smoothing, smooth signals to enhance clarity and stability. Noise suppression reduces unwanted noise for clearer signal processing. Next one, define of IIR filters. IIR systems, length of the unit sample response or impulse response H of n is infinite. IIR filters, the filter designed by considering all the infinite samples of impulse responses. We can generate the impulse response, we can going to design the filters, we can apply the filters and analyze the output. Next one, IIR filters. First, we can specify the IIR filter. We can define the desired characteristics of the IIR filter, transform to analog filter, convert the IIR filter specifications to an analog filter specification. We can design the analog filter, create an analog filter with transfer function H of S that meets the specification, and then transform to digital filter, convert the analog filter to a digital filter transfer function H of Z. Next one, we can see the comparison of digital and analog filters. Digital filter operates on digital samples of the signal. Analog filter operates on analog signals. Digital filter is governed by linear difference equation. Analog filter is governed by linear differential equation. Digital filter consists of adders, multipliers and delays implemented in digital logic. Analog filter consists of electrical components like resistors, capacitors and inductors. Next one, frequency response of analog IIR filter. It can be classified into four types: low pass filter, high pass filter, band pass filter and band stop filter. Low pass filter allow frequencies to a cutoff point. High pass filter above the cutoff point. Band pass filter allow the specific range of frequencies to pass through the attenuating frequencies. Band stop filter attenuates a specific range of frequencies while allowing frequencies outside the range of pass through. Next one, frequency response of analog and digital filter. It is of passband tolerance, stopband tolerance and ripples. The approximation problem is solved to meet a tolerance in the passband and stopband. Del of P, del of S are the limits of the tolerance in the passband and stopband. Del of P and del of S are also called as ripples. Next one, this is the specifications of practical analog IIR filter. That is, ohm P represents passband H frequency, ohm S stopband H frequency, omega P passband H frequency, omega S stopband H frequency, AP is nothing but gain at passband H frequency, AS gain at stopband H frequency. Next one, this is the ideate part. We are going to see the normalized magnitude response. This is the analog, ideal analog low pass filter. We can pass only the low frequencies. And the practical analog filter with respect to pass band and stop band, it is a transition band. We can going to low pass frequencies from pass band to stop band. Next one, this is the ideal analog high pass filter and low pass filter, low pass to high pass. We can stop the low frequencies, we can pass the high frequencies. That is the practical analog filter with respect to H of j ohm plus ohm. Next one, ideal analog band pass filter. We can pass only the frequencies. We can stop the frequencies at specific range. We can pass the frequencies from omega C1 to omega C2. This is the practical analog filter with the cutoff frequency of pass band, transition band and stop band. Next one, normalized magnitude function. We can pass only the high frequencies, we can stop only the low frequencies of the band pass filter. This is the practical analog band stop filter with respect to stop band, transition band and pass band. Next one, we can going to see the analog IIR filter, stability check, frequency response verification, plot analysis, performance evaluation. Stability ensuring system stability to pole analysis. Frequency response verification, validating a system response across frequencies. Plot analysis, interpreting magnitude and phase plots. Performance evaluation, comparing ideal and actual system responses. This is the mind map of IIR filter, analog IIR filter, the key characteristics, advantages, classification by frequency response, design parameters, design and analysis, and performance and limitations. Key characteristics of infinite impulse response, basics for digital IIR filter, linear differential equation and electrical components. Design parameters are tolerance limits, passband ripple, stopband ripple, transition band and cutoff frequencies. Next we can going to see the assessment. Define IIR filter. The filtered by considering all the infinite samples of impulse response is called as IIR filter. Based on the frequency response, the filters are classified into 4 basic types. They are low pass filter, high pass filter, band pass filter and band stop filter. Compare analog filter with digital filter. Digital filter operates on digital samples. Analog filter operates on analog signals. Digital filter is governed by linear difference equation. Analog filter is governed by linear differential equation. The analog filter is transformed to digital filter by using either bilinear transformation or impulse invariant transformation. The del of P and del of S are also called as ripples. Thank you.